Hello, so let's look at a calculus problem here. We have the integral going from 1 to 2 of e to the 1 over x, all divided by x squared dx. Okay, well, looking at this integral, how the heck we go ahead and start this? We know that the integral of just e to the x is e to the x. But looking at the exponent on e, we have e to the 1 over x. Now, what is the derivative of 1 over x? Well, if we just let u, doing a u substitution here, and letting u be equal to the exponent on e, so letting u be equal to 1 over x. Now, 1 over x, that's the same thing as x to the negative 1th power. So 1 over x is just going to be equal to x to the negative 1. And then what would be the derivative here? Well, if u would be equal to 1 over x, then the derivative du would be equal to, well, the negative 1 comes down. We get negative x to the negative 1 minus 1. So we get du would be negative x to the negative 2th power. Now, negative x to the negative 2 is, that's equal to, well, x to the negative 2 is 1 over x to the 2. So negative x to the negative 2 is negative 1 over x to the 2. Negative 1 over x to the 2. Now, looking at our integral, we have a 1 over x to the 2, because there's a 1 out in front of the e to the 1 over x. So we have that 1 over x squared. This is going to be a negative 1 over x squared. So if du is equal to negative 1 over x squared, that means that negative du would be equal to just, well, 1 over x squared dx. So then, if we do a u substitution here, and we have the integral going from 1 to 2, instead of now e to the 1 over x, we're letting u be equal to 1 over x. So therefore, our integral is just going to be e to the u, and then everything else, the 1 over x squared dx, well, that can be replaced by negative du, So we have negative du, well, the negative can come actually out front of the integral. So we have negative the integral from 1 to 2 of e to the u du. Now, if we go ahead, we have a definite integral, so we're going to be evaluating this at the end. There's going to be no plus c. We're just going to get a number out. And we can actually go ahead and change our bounds of integration, because now we're in terms of u rather than x. So what is, if u is equal to 1 over x, the bounds are going from 1 to 2. So when x is equal to 1, what is u? Well, when x is equal to 1, u is equal to just 1 over x. So that's 1 over 1. That's still 1. So when x is 1, u is also equal to 1. How about when x is equal to 2? Well, when x is equal to 2, u is equal, again, to 1 over x. So therefore, when x is 2, u is 1 over 2. So therefore, u is 1 over 2, or 1 half. So our bounds are 1 and 1 half. So we're going from, instead of 1 to 2, we're going like from 1 to 1 half. But since we have a negative outside of the integral, we can actually make this a positive integral and just change the bounds of integration. So a negative outside just changes the bounds of integration. So therefore, we can have the integral, instead of going from 1 to 1 half, we have the integral going from 1 half to 1. So the integral going from 1 half to 1 of just e to the u du. And this is now a very simple integral. Because the integral of e to the u is e to the u, because the e to the x function is so nice. It's the only function that has the derivative equal to itself. So since the derivative of e to the x is e to the x, the integral of e to the x, or e to the u in this case, is also e to the u. So this is equal to e to the u, but then we're evaluating from 1 half to 1. So we have e to the u, evaluating this from 1 half to 1. So all we do is we put in the upper bound first and subtract off what we get, we put in the lower bound. So therefore, this is equal to e to the 1 minus e to the 1 half. Well, e to the 1 is just e, and e to the 1 half, remember, anything to the 1 half power is the square root of that number. So e to the 1 half is the square root of e. So therefore, this is just equal to e minus minus the square root of e. And there we have it. This integral is going to evaluate to e minus the square root of e, and that was not very bad, right? Not very hard at all to evaluate this integral. So calculus actually can be not very hard at all. All right, calculator, take care.